going to be doing, you're looking at a cereal box, and we're trying to minimize the amount of material that we need. Just in case, so you see over here, oh, that was the wrong color to use, but page 196 and 200, they have steps on how to do a lot of these optimization problems. You don't have to copy it down, but just so you know that they're there. Okay, so in general, anytime you're starting one of these questions, you want to start with a diagram where it's possible. So this, we're making a rectangular prism. It's possible to draw that shape, so let's do that. So with your rectangular prism, you were told the thickness of it. So if you were to grip this cereal box, the thickness had to be what? 10. So we know this has to be 10. The other dimensions we don't know, so let's just label them. W, width, and we'll say that that's our height. So that's right. The material is the amount that's going to cover the box. So if you're seeing all these sections of covering the box, that's the area. So that's the other one, is your surface area. Now when you look at it, we actually know equations. We know an equation for volume, and we know an equation for surface area. So let's write those down. So those will be the two equations based on that rectangular prism. Does that make sense? Well, now let's put in things that we know. So going back to the volume, we have variables there that we know. We know what the volume is, right? We know that it's 5,000. We also know what the length was. We called it thickness. We know that it's 10. So can we isolate this a little bit? So that, perfect. So we'll divide by 10. So we have the 500 equals width times height. So if we isolate it, we have W equals 500 over H. So now we're going to use that in our surface area equation. So let's substitute in. Surface area equals, do we know what height times W is? So we're going to put in 2 times H times 500 over H plus 2 times 10 times H plus 2 times 10 times 500 over H. And then you can simplify again. So there's your surface area equation. So if we go and we find the derivative of our S of A, I'll let you do that first. So the max or min is going to happen when it equals 0. And you can solve for H. We can simplify so it's H equals plus or minus 10 root 5. When you're looking at a question with a height, we have a plus and a minus. Can we have a minus height? No. So we can say here that the H has to be greater than 0. So we can ignore the negative case. The only issue here is you can't assume that that's a maximum or a minimum. So we have to figure out, is it a maximum or minimum? Because if it's a maximum, then we haven't minimized the amount of material. So how can we tell if this is a maximum or a minimum? So with that second derivative, we're just going to take this, the only one we have because we ignored the negative case, and we're going to substitute it in. So we're going to put 20,000, 10 root 5 cubed. Is this positive or negative? And so since it's positive, we know that we have a local min here, which is perfect because we want to minimize the number of material, the amount of material, so we know that we're at a minimum. So that's the perfect variable. So now we know that this works. We need to know what are our dimensions. That was the whole question. What dimensions minimize the amount of material? How do we solve for W? Do we have an equation? Perfect. When you go back here, we had an equation since we know H, and we just substitute in 500 divided by that value, and what do we get? So those are the dimensions which minimize the amount of material to use on the cereal box. What if the question said, at what surface area is it minimized? What would you do? You would take those dimensions right here, and you would plug them back into your equation up here. And that would give you at what minimum you. Here are your steps for the beige, or if you got a blue sheet. And there's the equation that we're going to do the example. So I'll give you a chance to copy it. So the first part, number 1, the domain is x, e, r. How do we find the x-intercepts? We set y equal to 0. How do we find the y-intercepts? Set x equal to 0. So for the x-intercepts, what are you going to have to do since this is a cubic? So you'll have to factor using synthetic or long division. So there's your x-intercept, y-intercept. In order to sketch these, you want to have the whole coordinate, which means you would have had to sub in 3 into your original F and 1 into your original F. So it's actually 3 comma negative 4 and 1 comma 4. And if you had to classify, which did each one classify to be? So now you have these points that you can put on your graph, and you know you have a maximum and you know you have a minimum. How could you have found each of those? What were your options? Second derivative test or the interval chart, using the first derivative interval chart. That should be your POI, and again, like I said, you find this from plugging in f of 2. Once you have all of your points to find the y coordinate, you always go back to your original function. So that's your concavity. Your increasing and decreasing is it is increasing for negative infinity to 1 and 3 to infinity, and your decreasing is 1 to 3. So to do the sketch, you're just going to put in all of these points, and then you can check with concavity, but you basically just end up playing connect the dots, and there's your exact graph. So after you plot all the points, there's your graph, and make sure you label all of your parts.